Bismillahirrahmanirrahim. In continuation of our previous lecture, Introduction to Differentiation, in which we have discussed the Initio method, in which we have discussed the 4 steps, and today we are going to start the exercise questions of chapter 2 FSC book. So exercise 2.1 that is going to be completed today. So starting from question 1, part 1, here we have to solve again by using the definition method and calculate the derivative with respect to x for the given function. So the given function is y is equal to 2x square plus 1. So again the 4 steps which we have discussed in our previous lecture, those were the first step was we have to calculate y plus delta y, means the slight change in the function x, that is y. If we take y plus delta y, then we have to take x plus delta x on the right hand side. Similarly, in the second step we have to find delta y, that is equal to function of x plus delta x minus f of x. In third step we have to divide it by delta x, and in the fourth step we have to apply the limit. So by using these 4 steps we are able to find the derivative of the given function by using the ab initio method or the definition method or the principal method. So let's start it today by from question 1 part 1. So in question 1 part 1 the function is 2x square plus 1. So in step 1 we have to calculate our y is equal to 2x square plus 1. So we have to calculate y plus delta y, that will be equivalent to 2 into x plus delta x. In place of this x we have to replace it by delta x. X plus delta x, we add plus delta y, here we add plus delta x, and it's square over here, then add plus 1. So our delta y is equal to, now we have to simplify this one. So our delta y is equivalent to 2 into x plus delta x whole square plus 1, and this y will become minus y on the other hand side. And now in place of this y we have to put the value of the function, that is equal to 2x square plus 1. So here I am writing this value 2x square plus 1 in place of this y, that will be moved from the left hand side to the right hand side, and that will become negative. So now again by applying the algebraic expression formula a plus b whole square, and then by simplifying this equation, that will become 2 into x square plus 2x delta x plus delta x whole square, then plus 1, and by applying minus on this given function f of x, this will become minus 2x square, and this minus into plus minus, this will become minus 1. So this minus plus 1 and minus 1 will be cancelled over here. Now multiplying this whole equation with 2, this will become 2x square plus 4x delta x plus 2 into delta x whole square, this will become 2 delta x square minus 2x square. Again this 2x square will be cancelled with this minus 2x square. So our remaining term is 4x delta x plus 2 into delta x whole square. So in these two terms, by taking delta x common, the remaining term will become, if we take delta x common, this will become 4x plus 2 delta x. So we have simplified this term. After simplification, in step 2 we have to follow step 3, in which we have to divide it by delta x. So in step 3 we have to divide this whole term 4x plus 2 delta x whole divided by delta x. So after dividing it with delta x, this term will be cancelled. And then in step 4, we have to apply the limits. So limit delta x approaches to 0, 4x plus 2 delta x. So after applying limit, this is equal to 4x, because when we multiplied with 2 with delta x as approaches to 0, 2 multiplied by 0 is equal to 0. So our resultant value is equal to 4x. So the derivative of y is equal to 2x square plus 1, that is equal to 4x. So this is solution for part 1 of question 1 exercise 2.1. 2 minus square root of x. So this is another function. We have to find the derivative of this function by using the principal method or the definition method. So in first step 1, we have to take 5 plus delta y. So this will be equivalent to 2 minus square root of x plus delta x. Means we have slight increase in the function y there up to delta y. So on the right hand side, this will become x plus delta x. So now our delta y is equivalent to 2 minus square root of x plus delta x minus y. So this y will become minus on the other side of the equation. Now our delta y is equal to 2 minus square root of x plus delta x minus, we put value of y over here. Our value of y is equal to 2 minus square root of x. So we write 2 minus square root of x in place of this y. Now delta y is equal to 2 minus square root of x plus delta x minus 2 plus square root of x. So now this minus 2 will be cancelled by plus 2, and the remaining function is delta y is equal to square root of x. This is positive, so we write it first, and then this is negative, we write it second function, x plus delta x. So this is our delta y. Now we have to simplify this one, and then after simplification we move towards the third step, in which we have to divide it by the delta x on both sides of the equation. So for this one, this will become x power 1 by 2 minus, here we write it in this way, this is x power 1 by 2. If we take x common from these two terms, so here I am write it on the, here solve it separately. So this is x plus delta x power 1 by 2. If we take x power 1 by 2, this will become x power 1 by 2. Here in place of this x, we have 1 plus delta x over x whole power 1 by 2. If you will multiply this term with 1, this will become x power 1 by 2. And this x power 1 by 2 is cancelled with x power 1 by 2. So we have remaining term delta x and whole x power 1 by 2. So after simplification, we can write it in this way, x power 1 by 2 into 1 plus delta x over x power 1 by 2. So now this is basically a we can expand this value by using the binomial theorem, or we use the binomial expansion up to one term or two term, and then we simplify it. So by using the binomial expansion, in binomial expansion we have 1 plus x power n, this is equal to, according to binomial theorem, this will become 1 plus nx. In first term, this n will be multiplied by this value x plus n into n minus 1 over 2 factorial into x square. So in place of this x, if there is some other function, so we'll take the square of that function as well. So this will be the binomial expansion for given binomial 1 plus x power n for any given function. So if we take this one, 1 plus x delta x over x power 1 by 2, so this will become 1 plus 1 by 2 into n into x. So our x is delta x over x plus n 1 by 2 into n minus 1, 1 by 2 minus 1, n into n minus 1 over 2 factorial into x square. Our x is delta x over x, so we write it delta x over x whole square. So this will be simplification of this term by using the binomial expansion. So now we use these expansions over here in this term. So here we write it in this way: x power 1 by 2 minus x power 1 by 2 into, I'm directly writing this value over here, so 1 plus 1 by 2 into x delta x over x, 1 plus nx, 1 by 2 into this x plus n 1 by 2 into n minus 1, 1 by 2 minus 1 over 2 factorial into x square delta x over x whole square. So this will be the expansion of this binomial term. So after expansion, we again have to simplify this one. So we use simplification here. So x power 1 by 2 minus x power 1 by 2 into 1 plus 1 by 2 into delta x by x plus 1 by 2 into 1 by 2 minus 1 whole divided by 2 factorial into delta x by x whole square. So now by taking this minus sign, or firstly we multiply this term with this whole term, so this will become x power 1 by 2 minus x power 1 by 2 into 1, this will become x power 1 by 2 plus, so this minus will become again multiplying with plus, this will become minus 1 by 2 x power 1 by 2 into delta x over x whole delta x over x, and for last one this will become minus x by 2 into x power 1 by 2, this minus again will become minus after multiplying it with this plus, so minus x power 1 by 2, and the remaining term will become same as it is, 1 by 2 into 1 by 2 minus 1 into delta x over x whole square divided by 2 factorial. So this x power 1 by 2 will be cancelled with this term, and now in these two terms, if we take delta x by x common, so this will become delta x by x into minus 1 by 2 x power 1 by 2 minus x power 1 by 2 into 1 by 2 into 1 by 2 minus 1 whole divided by 2 factorial into delta x over x whole square. So this is a simplification of the second step. Now in the third step, we have to divide the both sides with delta x. So on the left hand side, this will become delta y by delta x. So delta y by delta x is basically dy by dx, or the differential. So this is equivalent to delta x by delta x into this x we divided by delta x and multiplied with this term x in the denominator. So the remaining term remains the same, minus 1 over 2 x power 1 by 2 minus x power 1 by 2 into 1 by 2 into 1 by 2 minus 1 over 2 factorial into delta x over x. So now we have taken delta x over x common, so this square will be converted into single term. So this will become single term. Now this delta y by delta x will become dy by dx, and this is equal to 1 by x into this whole term remains same as it is. And now in the last step, step 4, we have to apply the limit. So we write it in the same way. After applying limit, we write it as dy by dx. So now applying limit on the both sides of the equation. So this will become in next step we have to apply limit over here. So limit delta x approaches to 0 on this side, we have delta y by delta x. This is equal to limit delta x approaches to 0, and this first term will become minus 1 by 2 x, and this x power 1 by 2 will become square root of x. So, and the second term will become minus square root of x into 1 by 2 into 1 by 2 minus 1 over 2 factorial into delta x whole divided by x. So after applying limit, this second term will become 0. Due to delta x, that delta x approaches to 0, we only have the first term, that is called the remaining term. So this will become minus square root of x whole divided by 2x. So again, if we simplify this one, so if we write it in this way, minus square root of x divided by 2 into square root of x into square root of x. We write this x into this way, square root of x into square root of x, that is square root of x square, that is equivalent to x as well. So this x will be cancelled with the square root of x in the denominator, and the remaining term, our dy by dx, that is equivalent to minus 1 by 2 into x. So this will be the result for this second question by using the AB Initio method. Okay, in third part, we have another function y is equal to x power minus 1 by 2. That is 1 over x power 1 by 2. We can write it as y is equal to x power minus 1 by 2. So by following step 1, we have y plus delta y. This is equal to x plus delta x whole power minus 1 by 2. And our delta y is equal to x plus delta x whole power minus 1 by 2 minus y. This y will become minus on the other side of the equation. So our delta y is equal to x plus delta x power minus 1 by 2, and in place of this y we have x power minus 1 by 2, as y is equal to x power minus 1 by 2. We place the value of y over here, x power minus 1 by 2. Now again, in this expression we have to take x power minus 1 by 2 common, and then by using the binomial expansion as we did in the previous question. So x power minus 1 by 2 into 1 plus delta x whole divided by x power minus 1 by 2 and minus x power minus 1 by 2. So this term is multiplying with this term. We take x power minus 1 by 2 common from this term, and now x power minus 1 by 2 and x power minus 1 by 2, that is in both the terms, so we take x power minus 1 by 2 common. So delta y is equal to x power minus 1 by 2 into 1 plus delta x by x whole power minus 1 by 2, and in place of x power minus 1 by 2 we write minus 1 because x power minus 1 by 2 is taken as a common. Now applying the binomial expansion on this question, 1 plus x power n, so that is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square. By taking two terms of the binomial expansion and reduce this term. So our delta y is equal to x power minus 1 by 2 into 1 plus nx. So 1 plus n is minus 1 by 2. So plus into minus minus. So this will become 1 minus 1 by 2 into our x is delta x divided by x. So this will become 1 plus nx because this n value is minus. So plus multiplied by minus, this will become minus. So 1 plus nx, now plus n is minus 1 by 2 into n minus 1 minus 1 by 2 minus 1 over 2 factorial into x square. Our x is delta x over x. So delta x by x whole square. So this is expansion of this term, sorry. So we write minus 1 here as well. So this plus 1 and minus 1, they are cancelled with each other, and our remaining term will become delta y. This is equal to x power minus 1 by 2 into minus 1 by 2x into delta x. This 2 will be multiplied by this x, and we have delta x in the numerator. And the remaining term plus minus 1 by 2 into minus 1 by 2 minus 1 over 2 factorial into delta x by x whole square. We can write it in the same way here, delta x by x, because in these two terms our delta x by x will be taken as common. Or we can take delta x common as well in both of these terms. Anyhow, we can write it in this way, delta y is equal to x power, we divide this, use third step. I'm not going to repeat this one again. So by using third step, we have to divide it by delta x on both sides of the equation. So on the left hand side, this will become delta y by delta x. This is equivalent to this will become minus 1 by 2x, and this will be multiplied by x power minus 1 by 2 into delta x, or we take delta x common from both of them. So we take, this is our delta y by delta x, this is equal to, in this term we take delta x common from this upper term, from this delta x and this delta x square, that will become single delta x. So divided by delta x, as we divided on the right hand side by delta x, so here we divide this whole term by delta x. So the inner term will become 1 minus 1 by 2 into multiplied by this x power minus 1 by 2. This delta x is taken as common and divided by x. Similarly, for the second term, this will become plus this x power minus 1 by 2 will be multiplied by with the second term as well. So that will become x power minus 1 by 2 plus, into minus 1 by 2 into minus 1 by 2 minus 1 whole divided by 2 factorial, and here we write delta x over x and plus so on for the next expansion terms of the binomial expansion, because it's not going to be until minus 1. So here this delta x will be cancelled with this delta x, and now by using the step 4 we have to apply the limit on both sides of the equation. So by applying limit, this will become limit delta x approaches to 0 delta y by delta x, this is equal to limit delta x approaches to 0. Applying limit individually on both terms, we can apply that, or we can write that in bracket and apply single limit on both of them. So we can do that either taking limit individually or taking limit on the both of these two expressions. So I am applying individually, so this will become minus 1 by 2x x power minus 1 by 2 plus limit. Okay, by applying limit on both sides, here we have limit delta x approaches to 0 delta y by delta x, this is equal to, by applying individually limit on these two expressions, the first expression applying limit delta x tends to 0 minus 1 by 2x into x power minus 1 by 2, and for second expression again by applying the limit delta x approaches to 0, and this whole term minus 1 by 2 into minus 1 by 2 minus 1 into delta x whole divided by x. So after applying limit, this will become dy by dx and is equivalent to, this will become minus 1 by 2x, and this x power minus 1 by 2 we can write it over here as x power 1 by 2. So minus 1 by 2 into x power 1 by 2. So when it comes in the denominator, that will become positive. And for second term, when we apply a limit, this whole term will become 0. So our dy by dx, this is equivalent to minus 1 by 2 into x power 1 and x power 1 by 2 both have the same base, so the powers will be added with each other. So this will become x power 1 plus 1 by 2, or this is equal to minus 1 by 2 into x power 3 by 2. So this will be the dy by dx for this given function y is equal to x power minus 1 by 2. Next part 4, question 1. So the function is y is equal to x power minus 3. 1 by x power 3, we can write it as x power minus 3. So using step 1, we have y plus delta y, that is equal to x plus delta x whole power minus 3. So taking y on the other side of the equation, delta y is equal to x plus delta x power minus 3 minus y, and then by putting the value of y, this will become x plus delta x power minus 3 minus x power minus 3. So we insert the value of y is equal to x power minus 3 in place of y. So first step is completed. So second step is completed. So we have to simplify this step again. Here we can take x power minus 3 as common into 1 plus delta x over x whole power minus 3 minus x power minus 3. Again, we have the expression in this form. We have to apply the binomial expansion on this term, where this is equal to 1 plus x power minus 3, where the value of n is minus 3, that is equivalent to 1 plus nx plus n into n minus 1 by 2 factorial into x square, and so on up to second term. We have to take the expansion for binomial expansion for this given term. So this is equivalent to x power minus 3 into 1 plus nx. So this will become 1 minus 3 into delta x by x plus n plus minus 3 into n minus 1 minus 3 minus 1 whole divided by 2 factorial multiplied by x square over x is delta x by x. So we write it as delta x by x whole square plus so on the remaining terms in the expansion. So we only take the two terms of the binomial expansion. Now and then minus x power minus 3. So multiplying this x power minus 3 with this whole term, this will become x power minus 3 minus 3x power minus 3 delta x by x, and then plus x power minus 3 into minus 3 minus 1 whole divided by 2 factorial into delta x by x whole square, and then we write this term minus x power minus 3. So this plus x power minus 3 will be cancelled by this x power minus 3. They will be cancelled with each other. So this is value of delta y. We can take delta x common in both of these two terms here. So by taking delta x common, our delta y is equivalent to delta x divided by x into minus 3x power minus 3 plus x power minus 3. We can write it in simplified form as well. This is minus 3 minus 1, that will become minus 4, and minus 4 multiplied by minus 3, that will become plus 12. Plus 12 divided by 2 factorial, that is equal to 6. So that will become 6x power minus 3 and plus 6x power minus 3, and in place of this delta x by x whole square, as we have taken delta x by x as a common, so the remaining term will be delta x by x. So we have simplified the expression in the second step. In the third step, we have to divide both sides by delta x. So by dividing both sides with delta x, that is equal to delta y by delta x is equal to delta x divided by delta x into x, and the remaining term will be same as it is, plus 6x power minus 3 delta x by x. So this delta x will be cancelled by the delta x in the denominator. Then after that we have to apply limit on the both sides of the equation. So by applying limit, we have limit delta x approaches to 0, delta y by delta x. So this is equivalent to limit delta x approaches to 0 minus 3x cube plus limit delta x approaches to 0 6x power minus 3 delta x by x. So this term will become 0 as delta x approaches to 0. This whole term becomes 0. So our result is equal to dy by dx. This is equal to minus 3x power minus 3 plus 0, or we can write it as minus 3 over x power 3. So that will be the result of this. Sorry, we have one remaining term x over here as well. So we can write it as minus 3x power minus 3 whole divided by x. So this will become minus 3 over x power 3 and multiplied with this term x, this one. So this is equal to minus 3 by x power 4. So our dy by dx, this is equivalent to minus 3 by x power 4. So this will be the derivative of this given function 1 by x cube. Okay. So our next part is our function is 1 by x minus a. So we can write it as y is equal to x minus a power minus 1. So it's x minus a power 1 in the denominator. If we place them in the numerator, its power will become minus 1. So y plus delta y, this is equal to x plus delta x minus a power minus 1, and our delta y is equal to x minus a plus delta x. We can write it in this way as by placing a first and then delta x power minus 1 minus y, and then we place the value of y, that is equal to delta y is equal to x minus a plus delta x power minus 1 minus putting the value of y, x minus a power minus 1. So second step is completed. Now we have to simplify this step again by taking x minus a common from this whole term. That will become our delta y is equivalent to x minus a power minus 1 into 1 plus delta x by x minus a whole power minus 1 minus x minus a power minus 1. Again, we have to expand this term by using the binomial expansion. We have to take the up to x square, we have to take 3 terms of the binomial expansion. So our delta y is equal to x minus a power minus 1 into 1 plus nx. Our n is now minus 1. So minus 1 into this term, n into this whole term is x. So that will become 1 minus delta x by x minus a, then plus n minus 1 into n minus 1 minus 1 minus 1 whole divided by 2 factorial, and then we have to take the square of x. Our x is delta x by x minus a. We have to take the square of this term. So that will become delta x by x minus a whole square, and we have taken the expansion for that, and then at the end we have the term minus x minus a power minus 1. So our delta y is equal to, by multiplying this term with this whole expression after expansion, that is equivalent to x minus a power minus 1 when it is multiplied by 1. Then minus, this will become delta x divided by x minus a, and we can write it this term as x minus a power minus 1. In the denominator, this will become x minus a power 1. So when we multiply this whole term with the second expression, so x minus a will become into the denominator and multiplied with the previous x minus a term. For the last step, again we can write this x minus a power minus 1 as 1 over x minus a into, if we simplify this one, this will become minus 1, that is minus 2 multiplied by minus 1, that will become positive 2, and divided by 2 factorial. So 2 factorial and 2 will be cancelled with each other, and here we have the remaining term delta x by x minus a whole square, and at the end we have minus x minus a power minus 1. So minus x minus a power minus 1 and plus x minus a power minus 1, they will be cancelled with each other, and our delta y is equivalent to now we take delta x divided by x minus a as a common in both of these two terms. So the remaining term will become minus 1 by x minus a, and for this one we have taken common x minus a, so this is taken as a common. Delta x is also taken as a common, so the second term will become delta x by x minus a, as this x minus a square we have taken x minus a, this will become x minus a whole square, because this x minus a is taken common, one x minus a from this term and x minus a from this term, so this will remain as it is delta x square, as delta x is common, so it is right once in the expression and then x minus a whole square, so by taking delta x common. Now in the third step we have to divide the both sides with delta x. So now delta y by delta x, this is equal to delta x by delta x into x minus a and whole multiplied by minus 1 over x minus a plus delta x by x minus a whole square. So this delta x will be cancelled with the delta x in the denominator. Now applying the limit here, firstly or before applying limit, we multiply this term 1 over x minus a with both of these two terms individually, and then after simplifying that, we apply the limit by using step 4. So delta y by delta x, this is equal to minus 1 divided by this x minus a and this x minus a. If we multiply both of them, that will give us minus 1 by x minus a whole square, and for the second term we have delta x by, this is x minus a whole square, when we multiply it with x minus a, that will become x minus a whole cube. Now applying limit on both sides of the equation, we have limit delta x approaches to 0 minus 1 by x minus a whole square plus limit delta x approaches to 0 delta x by x minus a whole cube. So here in the second term, as delta x approaches to 0, this whole term will become 0, and our resultant value, on the left hand side we have the same value over here, this one delta y by delta x. So at the end we have dy by dx, that is equal to minus 1 over x minus a whole square. This will be the derivative for this given function 1 by x minus a. Can I start? Okay, our next function, part 5, in which we have the function is x into x minus 3. So we can write it as y is equal to x into x minus 3, or we can write it as y is equal to x square minus 3x. So this is our given function. We have to find the derivative of this function by using the ab initio method. So the first step, we have to take y plus delta y, slight change in the function, that is equal to x plus delta x whole square minus 3 into, in place of x we write x plus delta x, and then delta y is equal to x plus delta x whole square minus 3 into x plus delta x minus y, and our y is x square minus 3x. So we can write it as x plus delta x whole square minus 3 into x plus delta x minus x square minus 3x, that is replaced with y, as y value is equal to x square minus 3x. Now by simplifying, delta y is equal to, by taking a plus b whole square, that is equal to x square plus 2x delta x plus delta x whole square, and then multiplying 3 with these two terms, minus 3x minus 3 delta x, then minus x square, and then plus 3x. So this minus x square will be cancelled with this term, and plus 3x and minus 3x, they will be cancelled, and our remaining term is equal to, our delta y is equal to 2x delta x plus delta x square, and then minus 3 delta x. So all the three terms we have delta x common. So by taking delta x common, we have 2x plus delta x minus 3. So we have simplified and completed the second step. In the third step, we have to divide the both sides of the equation with delta x. So now we have to write delta y by delta x, that is equivalent to delta x into 2x plus delta x minus 3 whole divided by delta x. So this delta x will be cancelled, and our delta y by delta x is equal to 2x plus delta x minus 3. Then at the end, by applying limit on both sides of the equation, so we have limit delta x approaches to 0, delta y by delta x, this is equal to limit delta x approaches to 0 of this whole function, 2x plus delta x minus 3. So this is equivalent to dy by dx. So after applying limit, we have 2x, in place of delta x we have 0 and then minus 3. So dy by dx, this is equal to 2x minus 3. So this will be our required derivative for this given function. So in the next, we have a function y is equal to 2 by x power 4, or we can write it as y is equal to 2x power minus 4. Applying step 1, y plus delta y, this is equal to 2 into x plus delta x power minus 4, and then taking y on the other side of the equation, delta y is equal to 2 into x plus delta x power minus 4 minus y, and then by putting the value of y, delta y is equal to 2 into x plus delta x power minus 4 minus 2x power minus 4 by placing the value of y, that is equal to 2x power minus 4. Now by simplifying this equation, we have to take x power minus 4 common from this expression and making it as a binomial expansion. By applying binomial expansion, we are able to get the result for that. So delta y is equal to 2 into x power minus 4 into 1 plus delta x by x power minus 4 minus 2x power minus 4. So here for this 1 plus delta x by x power minus 4, we have to apply the binomial expansion as we did in the previous questions. So delta y is equal to 2 into, we can write it directly as 2x power minus 4 into, now apply binomial expansion on this given term. So that will become 1 plus nx. So 1 minus 4 into delta x by x. Our n value is minus 4. So minus into plus minus n into x, 4 into delta x by x plus n minus 4 n minus 1 minus 4 minus 1 whole divided by 2 factorial into x square, that is delta x by x whole square, and then the last term minus 2x power minus 4. So multiplying this term with this whole expression, that will become our delta y is equal to 2x power minus 4 when multiplied by 1, that is equal to 2x power minus 4, then minus 2 into 4, that will become 8, and delta x 8x power, we write it as 8x power minus 4 into delta x by x plus again 2x power minus 4 multiplied by this whole term, and we simplify this whole term, that will give us minus 4 minus 1, that will become minus 5, minus 5 multiplied by minus 4, that will become plus 20, and when we divide it by 2, that is will give us 10. So multiplied by 10 and multiplied by delta x by x whole square, and then this term minus 2x power minus 4. Now this minus 2x power minus 4 and minus 2x power minus 4 will be cancelled with each other. So our remaining term, we have to take delta x by x, we can take common out of these two expressions. So this will become, I am writing it directly, 2 into 10, that will become 20x power minus 4. So I am omitting one step and directly writing over here, that is equal to 20x power minus 4. So now by taking delta x over x common in from this expression, here we have minus 8x power minus 4 plus 20x power minus 4 into delta x divided by x. One delta x by x is taken as common, so its square will be cancelled as a written as a single term. So this is our simplification by using step 2. Then by using step 3, we have to divide both sides of the equation with delta x. So that will give us delta y by delta x, that is equal to delta x by x into delta x, the delta x which we have divided on both sides, and multiplied by minus 8x power minus 4 plus 20x power minus 4 delta x by x. So this delta x will be cancelled, and now again simplifying this one, delta y by delta x is equal to, we have one x remaining over here, we can write multiply this one with this value, that can be written as either, if we take it into the numerator, that will become minus 8x power minus 4 into x power minus 1, that will give us minus 8x power minus 5. Or if we take x power minus 4 in the denominator, that will become x power 4, and when x power 4 is multiplied with x, that will become x power 5. So we can write it as minus 8 over x power 5 plus 20 by x4 into delta x by x. So after simplification, we have to apply the limit on both sides of the equation by using step 4. So limit delta x approaches to 0, delta y by delta x, this is equal to limit delta x approaches to 0. I am writing directly as a whole term, not applying limit individually. You can apply limit individually and then both will give the same result. So minus at 8 by x5 plus 20 by x4 delta x by x. So when we apply the limit, this first term will remain as it is, that is minus 8 over x5, and for second term, as delta x is approaches to 0, this whole term will become 0. So our dy by dx, that is equivalent to minus 8 by x power 5. So this will be the derivative for that given function, 2 by x power 4. Okay, so part 8, we have the given function y is equal to x square plus 1 by x square. So we can write it in this way as well, y is equal to x square plus x power minus 2. So 1 over x square, we can write it as x power minus 2. So applying step 1, y plus delta y, this is equal to x plus delta x whole square plus x plus delta x power minus 2. And then taking y on the other side of the equation, this is equal to x plus delta x whole square plus x plus delta x power minus 2 minus y. And then by putting the value of y, this will become x plus delta x whole square plus x plus delta x power minus 2 minus x square plus x power minus 2. By putting the value of y from here in that place. So now we have to simplify this step 2. Firstly, by opening this expression, algebraic expression a plus b whole square, and then again by taking x power minus 2 common and converting it into binomial expression, and by applying the binomial theorem, we are able to get the result for that. Okay, so our delta y is equal to x square plus 2x delta x plus delta x square. So this will be result for the first term. In the second term, we have x power minus 2 into 1 plus delta x by x power minus 2, and then minus x square plus x power minus 2. So by taking the simplification, we have x square plus 2x delta x plus delta x square into, so this is multiplying by x power minus 2 into 1 plus nx, so 1 minus 2 into delta x by x, and then the third term plus n minus 2 into n minus 1 minus 2 minus 1 over 2 factorial into delta x square delta x by x whole square, and then the remaining term minus into x square plus x power minus 2. So now by taking the simplification, this will become, sorry, this is plus here, so it's not multiplication, so write plus in between these two. So delta y is equal to x square plus 2x delta x plus delta x whole square, then plus, because here we have plus sign, so by taking plus and multiply this x power minus 2 with this whole term, this will become x power minus 2 into 1, that will become x power minus 2 minus 2, this x power minus 2 when multiplied by x, that will become 2 over x cube delta x, and for this term again plus minus 2 minus 1 minus 3 multiplied by minus 2, that will become 6, and 6 divided by 2, that is equal to 3. So plus 3 over this x power minus 2 will be written as 3 by x power 2 into delta x by x whole square, and then we have complete the multiplication of x power minus 2 with all these three expressions, and then at the end minus x square, and then minus x power minus 2. So x square cancelled with minus x square, plus x power minus 2 and minus x power minus 2, they will be cancelled with each other. So the remaining terms we have delta y, this is equal to 2x delta x plus delta x square minus 2 by x cube delta x plus 3 by x square into delta x by x whole square. Now in these, all of these terms, we can take delta x common from all of these four terms, 1, 2, 3, 4 terms. So here we have delta x, in this term we also have delta x, here we can take delta x as common, and first term we can take delta x as common. So by taking, again simplifying this term, our delta y is equal to, take delta x common, then we have 2x plus delta x minus 2 by x cube, and for the last term we have, so here we delta x is taken as common outside, and for last term we have 3 by x square into delta x divided by, as delta x is taken common, here we have a square of that, and in the denominator we have x square. So we have taken delta x common from these four terms. Now by using step 3, we have to divide both sides of the equation with delta x. So we can write it as delta y by delta x. This is equal to delta x by delta x, that is multiplied with all these terms, 2x plus delta x minus 2 by x cube plus 3 by x square into, either we can write at 3 by x4, this x square will be multiplied by this x square, that will become 3 by x4, and this delta x. So here we have simplified this expression, and our delta x will be cancelled with delta x. Now by using the step 4, we have to apply the limit on both sides of the equation. So by applying limit, we have limit delta x approaches to 0, delta y by delta x. So this is equivalent to limit delta x approaches to 0, this whole term, 2x plus delta x minus 2 by x cube plus 3 by x4 delta x. So we have apply the limit on both the whole term. We can apply limit individually on each and every term. So I am directly, we have no more space over here, so I am directly applying the limit on all these four expressions. So for the on the left hand side we have dy by dx, that is equal to the first term 2x, in which there is no involvement of delta x, so that will be written as it is. So plus second term plus delta x, for as delta x is approaching to 0, so that is equivalent to 0. For the third term we have minus 2 by x cube, so that will be remain as it is. And for fourth term again we have delta x is multiplying with this term, so that whole term will become 0 as well. So we write it 0 over here. So our dy by dx, that is equivalent to 2x minus 2 by x cube. So this will be the result for this given function, and we have calculated the derivative by using the AB Initio method. So we have part 9, in which we have given this function y is equal to x plus 4 power 1 by 3. So we write it in this way: y is equal to x plus 4 power 1 by 3. So by using the first step, we have to take y plus delta y on the left hand side. On the right hand side, simultaneously we have to take x plus delta x in place of x. So we can write it in this way: y plus delta y, that is equivalent to x plus delta x plus 4 whole power 1 by 3. So by taking or moving y on the other side of the equation, we have delta y is equal to, we write 4 before delta x, so x plus 4 plus delta x whole power 1 by 3 minus y, and then by putting the value of y, this will become x plus 4 plus delta x power 1 by 3 minus x plus 4 power 1 by 3. We have to change the value of y, that is equivalent to x plus 4 power 1 by 3. Now by taking x plus 4 common from this given expression, and then by applying the binomial expansion, we are able to get the result for that. So delta y is equal to x plus 4 power 1 by 3 into 1 plus delta x by x plus 4 whole power 1 by 3 minus x plus 4 power 1 by 3. Now we have taken x plus 4 power 1 by 3 common from this whole expression. So now this is 1 plus x power n, and by applying the binomial expansion, that is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square and so on, we have to take the expansion up to x square and then neglect the remaining terms of the expansion. So here delta y is equal to x plus 4 power 1 by 3 into 1 plus, our n is 1 by 3, so 1 by 3 into x plus 4 delta x, 1 plus nx, so 1 by 3, that is n, and the value of x is delta x by x plus 4, so I have written x plus 4 here and separate the term delta x. Then the second term plus n, 1 by 3 into n minus 1, 1 by 3 minus 1 whole divided by 2 factorial, and then the second term delta x by x plus 4 whole square, and plus so on the remaining terms, and then at the end we have to write minus x plus 4 power 1 by 3. Now this x plus 4 is multiplying with all of these terms, and one thing in common is that delta x in this term and delta x in this term, so I am directly taking delta x common out of these two terms and multiplying it by x plus 4 power 1 by 3, or directly I am not writing, okay, we will have one more step for that. So x plus 4 power 1 by 3 multiplied by 1, that is equal to x plus 4 power 1 by 3 plus x plus 4 power 1 by 3 divided by 3 into x plus 4 delta x, and then plus, we can write it as it is because this term will become 0 x plus 4 power 1 by 3 into 1 by 3 minus 1, that is equal to, if we take the denominator LCM for that, 1 minus 3, that is equal to minus 2 by 3, and multiplied by 1 by 3, that will become, this is equal to minus 2 by 9, and in the denominator we have 2 factorial multiplied by 2, this will become minus 2 by 18. So 1 by 3 minus 1, that is equal to minus 2 by 3. This minus 2 by 3 is multiplying by 1 by 3, that is equal to minus 2 by 9. And then in division we have 2 factorial. When we multiplied it by 2, that will give us minus 2 by 18. So we write it as x plus 4 power 1 by 3 divided by, or this is minus 2. So here we have minus. So minus 2 by 18 and multiplied by this term x plus 4 power 1 by 3 and delta x by x plus 4 whole square minus x plus 4 power 1 by 3. So this x plus 4 power 1 by 3 and minus x plus 4 power 1 by 3 will be cancelled with each other, and we have these remaining terms. So we can write it this way. Our delta y, that is equivalent to, we can write it as well, x plus 4 power 1 by 3, and if we take it into the numerator, that will become x plus 4 power minus 1. Both have the same base. So 1 by 3 minus 1, again we can write it in this way, 1 by 3 into x plus 4 power 1 by 3 into x plus 4 power minus 1, this one. When we take this x plus 4 in the numerator, its power will become minus 1, and if we add these two, this will become x plus 4 power 1 by 3 minus 1, and if we take the LCM of 1 by 3 minus 1, again this will become 1 minus 3, that is equal to minus 2 by 3. So I am directly writing over here minus 2 by 3. So here we can write it as 1 by 3 x plus 4 power minus 2 by 3 into delta x. For second term, minus 2 by 18 x plus 4 power 1 by 3 into delta x by x plus 4 whole square. So here we can take delta x common out of these two terms. So we can write it in this way, that is equal to delta x into 1 by 3 x plus 4 power minus 2 by 3 minus 2 by 18 into x plus 4 power 1 by 3, and we write it as delta x by x plus 4 whole square. So one delta x is taken as common, so delta x square will be replaced by delta x. Now dividing the both sides with delta x by using step 3, we have delta y by delta x. This is equal to delta x by delta x into this whole term, that one as we write earlier. So now applying limit on both sides of the equation, so we have limit delta x approaches to 0, delta y by delta x, this is equal to, this will be cancelled. So we have these terms, two terms remaining. So limit delta x approaches to 0 into 1 by 3 into x plus 4 power minus 2 by 3 minus 2 by 18 into x plus 4 power 1 by 3 delta x by x plus 4 whole square. Same as it is, as we have taken delta x common, so the remaining term remain as it is. So this second term in which we have delta x involved, and that delta x approaches to 0, that whole term will become 0. So our dy by dx is equal to 1 by 3 into x plus 4 power minus 2 by 3, or we can write it as 1 by 3 into x plus 4 power 2 by 3. This will be the required dy by dx for this given function by using the AB Initio method. Okay, in part 10 we have a function y is equal to x power 3 by 2, for which we have to find the derivative for that by using the definition method or the AB Initio method. So starting step 1, y plus delta y, that is equal to x plus delta x whole power 3 by 2. Taking y on the other side of the equation, delta y is equal to x plus delta x power 3 by 2 minus y, and now by putting the value of y, that will become x plus delta x power 3 by 2 minus x power 3 by 2. So now again in this term we have to take x power 3 by 2 common, and then by using the binomial expansion we are able to simplify that. So delta y is equal to x power 3 by 2 into 1 plus delta x by x power 3 by 2 minus x power 3 by 2. By applying a binomial expansion, so 1 plus x power n, that is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square, by taking the expansion up to x square only and omitting the remaining terms. So x power 3 by 2 into 1 plus 3 by 2x delta x plus 3 by 2 n into n minus 1, 3 by 2 minus 1 over 2 factorial into x square, that is delta x by x whole square, and then so on. Remaining terms will be neglected, and x power 3 by 2, the value of y. So our delta y is equal to x power 3 by 2 multiplied by 1, that will remain as it is, plus 3x power 3 by 2 divided by x delta x plus 3 by 2 minus 1, that is equal to, we take LCM 2, this will become 3 and minus 2, that is equal to 1 by 2. So 3 by 2 minus 1, that is equal to 1 by 2, and 1 by 2 multiplied by 3 by 2, that will become 3 by 4, and multiplied by 2 factorial, that will give us 3 by 8 into x power 3 by 2 into delta x by x whole square minus x power 3 by 2. So this x power 3 by 2 will be cancelled by x minus x power 3 by 2. Now in these two terms we have to take delta x common. So delta y is equal to, so if we take x in the numerator, that will become x power 3 by 2 into x power minus 1. When this x will be taken in the numerator, its power will become minus 1. So the whole power will become x power 3 by 2 minus 1. So that is equal to x power 1 by 2, as 3 by 2 minus 1 is equal to 1 by 2. So we have x power 1 by 2. So in place of this one, firstly by taking delta x common, then in place of this we can write it as 3x power 1 by 2 plus 3 by 8, 3 by 8x power 3 by 2. So this is delta x square, we have taken delta x common. So the remaining term is delta x divided by this x whole square. So we have simplified this term. Then for the third step, we have to divide delta x on both sides of the equation. Now by dividing delta x on both sides of the equation, we have delta y by delta x, that is equal to delta x divided by delta x into 3x power 1 by 2, sorry 3 by 2, we have omitted this 2, so 3 by 2x power 1 by 2. So 3 by 2x power 1 by 2 plus 3 by 8 x power 3 by 2 into delta x over x square. So this delta x will be cancelled with the delta x in the denominator. So now by applying the limit on both sides of the equation, we have limit delta x approaches to 0, delta y by delta x, this is equal to limit delta x approaches to 0 for this whole function, 3 by 2x power 1 by 2 plus 3 by 8x power 3 by 2 delta x by x square. So now by applying limit, this second term will become 0 as delta x approaches to 0. So our dy by dx, this is equal to 3 by 2x power 1 by 2, or we can write it as 3 by 2 under root x. So this will be our required derivative for this given function by using the AB initio method. In part 11 again we have another function y is equal to x power 5 by 2, for which we have in part 11 again we have another function y is equal to x power 5 by 2, for which we have in part 11 again we have another function y is equal to x power 5 by 2, for which we have in next part we have another function y is equal to x power 5 by 2, for which we have to calculate the derivative by using the AB initio method. Now following the first step, we have y plus delta y is equal to x plus delta x whole power 5 by 2. By taking y on the other side of the equation, that will become x plus delta x power 5 by 2 minus y, and then by putting the value of y, that will become x plus delta x power 5 by 2 minus x power 5 by 2. Now in this equation we have to take x power 5 by 2 common and converting it into binomial expansion, and then by applying the binomial theorem we are able to simplify this expression. So here delta y is equal to x power 5 by 2 into 1 plus delta x by x power 5 by 2 minus x power 5 by 2. So delta y is equal to x power 5 by 2 into 1 plus nx. Our n is 5 by 2, so we write it as 5 by 2x delta x. When 5 by 2 is multiplied by x, that is delta x by x, that will become 5 by 2x delta x plus n, 5 by 2 into n minus 1, 5 by 2 minus 1 divided by 2 factorial into x square, that is delta x by x whole square, and then neglecting the remaining terms, minus x power 5 by 2, that is the last term, the value of y. Now multiplying x power 5 by 2 with this whole expression, x power 5 by 2 multiplied by 1 is x power 5 by 2 plus 5x power 5 by 2 divided by 2x delta x plus 5 by 2 minus 1 is equal to 3 by 2, and 3 by 2 multiplied by 5 by 2, that will become 15 by 4, and multiplied by 1 by 2, that is equal to 15 by 8. So 15 by 8 x power 5 by 2 into delta x by x whole square minus x power 5 by 2. So we have simplified this one. I am repeating it once more. 5 by 2 minus 1, that is equal to 3 by 2. 3 by 2 multiplied by 5 by 2, that is 15 by 4. Having 2 factorial in the denominator, so 15 by 4 multiplied by 2, that will become 15 by 8. This whole term when multiplied with x power 5 by 2, that will be x power 5 by 2, and then the second term delta x by x whole square. Now x power 5 by 2 will be cancelled with x minus x power 5 by 2, and our delta y, now I am taking delta x common from out of these two terms, so that will become delta x into this one. We have 5 by 2 into x power 5 by 2 into x power minus 1. So 5 by 2 minus 1, that will become x power, base is same, so 5 by 2 minus 1, that is will be 3 by 2. So I will change that in the next step, plus 15 by 8 x power 5 by 2. For this delta x here, we have taken delta x as common, so we write it as delta x divided by x square. So if we take x square in the numerator, that is x power 5 by 2 minus 2, so that is x power 1 by 2, but we don't need that because this whole second term will become 0, so we don't need simplification for that. So now I am writing it once more. Delta y is equal to delta x into 5 by 2 x power 5 by 2 into x power minus 1. So 5 by 2 minus 1, that is equal to 3 by 2. 5 by 2 minus 1 by taking LCM. 5 minus 2, that is equal to 3 by 2. So write it as 5 by 2 x power 3 by 2. Then plus 15 by 8. We have x power 5 by 2 into x power minus 2. 5 by 2 into x power minus 2, we can write it as 5 by 2 minus 2. So we have 5 minus 4 by 2, or that is equal to 1 by 2. So we write it as 15 by 8 x power 1 by 2 into delta x. So we have simplified that. Now by using step 3, we have to apply the divided by delta x on both sides of the equation. So we write it as delta y by delta x, that is equal to delta x by delta x into 5 by 2 x power 3 by 2 plus 15 by 8 x power 1 by 2 delta x. So this will be cancelled. And now applying the limit on both sides of the equation by using the step 4, we have limit delta x approaches to 0, delta y by delta x, that is equal to limit delta x approaches to 0, this whole function 5 by 2 x power 3 by 2 plus 15 by 8 x power 1 by 2 into delta x. So after applying limit, we have the second term, this term, that will become 0 because it has delta x involved and our delta x is approaching to 0. So we write it as dy by dx is equal to 5 by 2 x power 3 by 2. So this will be our required derivative for this given function by using the principal method. We have another question in which we have a different function y is equal to x power m, and we have to find the derivative by using the principal method. So by using the first step, we have to take y plus delta y, that is equal to x plus delta x power m, and then taking y on the other side, that is equal to x plus delta x power m minus y, and then by inserting the value of y, x plus delta x power m minus x power m. So here we have completed step 2, and now we have to simplify this by taking x power m common and applying converting it into binomial expression, and then by applying the binomial theorem to reduce this term. So our delta y is equal to x power m into 1 plus delta x over x power m minus x power m. So by using binomial expansion, this will become x power n 1 plus nx. Our n is m, so this will become m over x delta x plus m. This is our n minus 1, that will be m minus 1 over 2 factorial into delta x square, that will be delta x over x whole square, and neglecting the remaining terms minus x power m. So our delta y is equal to x power m multiplied by 1, this will become x power m plus x power m, and this is x power 1, I am taking it into the numerator, so multiplying it by these two terms with m. So we write it as m into this x power m into this x power minus 1 into delta x plus x power m into m square minus 1. M into m square minus, m square minus m whole divided by 2 factorial into delta x by x whole square minus x power m. So here I have multiplied x power m with 1, that will be x power m plus x power m into x power minus 1 into delta x, and for the last term x power m into this whole term into delta x by x whole square. So this x power m will be cancelled by minus x power m, and our delta y is equal to mx power m minus 1. Because both the base are same, the power will become mx power m minus 1, and delta x plus x power m into m square minus m divided by 2 factorial into delta x square divided by x square. Now both the terms have delta x so involved, so we take delta x common out of these two terms. So our delta y is equal to delta x into mx power m minus 1 plus x power m into m square minus m divided by 2 factorial into delta x by x square. So here we have simplified this by using the second step. In the third step, we have to divide both sides of the equation with delta x. So by taking the division of delta x on both sides, we have delta x by delta x into mx power m minus 1 plus xm into m square minus m divided by 2 factorial into delta x by x square. So this delta x will be cancelled with each other, and now by using step 4 we have to apply limit on both sides of the equation. So here we have limit delta x approaches to 0, delta y by delta x is equal to limit delta x approaches to 0 mx power m minus 1 into plus x power m into m square minus 1 m square minus m whole divided by 2 factorial into delta x by x square. So this second term in which we have delta x involved and that approaches to 0, so the second term will become 0 after applying the limit. So our dy by dx is equal to mx power m minus 1, and that will be our required derivative for this given function by using the ab initio method. We have another function y is equal to x power minus 100, and we have to find the derivative for this given function by using the principal method. So using step 1, y plus delta y is equal to x plus delta x power minus 100. So by taking y on the other side of the equation, our delta y is equal to x plus delta x power minus 100 minus y. And then by putting the value of y, that is equal to x plus delta x power minus 100 minus x power minus 100. Now we have to simplify this one again by taking x power minus 100 common and making it the binomial expression, and then apply binomial theorem to reduce that expression. So here we have delta y is equal to x power minus 100 into 1 plus delta x by x power minus 100 minus x power minus 100. So by applying binomial expansion, we have x power minus 100 into 1 plus nx, that will become 1 minus 100 over x into delta x plus n minus 100 into n minus 1 minus 100 minus 1 whole divided by 2 factorial into x square, that is delta x by x whole square, and remaining terms will be neglected, minus x power minus 100. So here we have applied the binomial theorem and expand this term by using the binomial theorem, 1 plus x power n. So that is equal to 1 plus nx plus n into n minus 1 by 2 factorial into x square plus so on. The remaining terms are neglected, and then at the end we have the value of y, that is x power minus 100. So multiplying this x power minus 100 with the these terms, that will become delta y is equal to x power minus 100 into 1, that will become x power minus 100 minus x power minus 100 into x power, this x will become minus 1 into, we will write 100 before that, or multiplied by 100 into delta x plus this term minus 100 into minus 101 whole divided by 2 factorial into delta x by x whole square minus x power minus 100. So this x power minus 100 and minus x power minus 100, that will be cancelled with each other. So we have the remaining term, that is equal to delta y is equal to minus x power minus 100 and minus 1, that will become minus x power minus 101. Minus 100 and minus 1, that is minus 101. And before that we have to write, here we have to write minus 100 x power minus 101. This 100 is also multiplying with all these terms into delta x plus the remaining term, that will be taken as it. So here I am taking delta x common out of these terms. So write it in this way, delta y is equal to delta x into minus 100 x power minus 101, delta x is taken as common, plus minus 100 into minus 101 whole divided by 2 factorial into delta x by x square. As delta x is taken as common, so delta x square will be replaced by delta x. So we have simplified this term. Now by taking the dividing it by delta x on both sides of the equation, we have delta y by delta x, that is equal to delta x by delta x into minus 100 x power minus 101 plus remaining term will be taken as it is. So this will be cancelled, and in the last step, by applying the limits on the both side of the equation, we have limit delta x approaches to 0, delta y by delta x, that is equal to limit delta x approaches to 0 into minus 100 x power 101 plus minus 100 into minus 101 over 2 factorial into delta x by x cube. So after applying the limit, here we have delta x involved and that approaches to 0. So this whole term will become 0. So our dy by dx is equal to minus 100 x power minus 101. So this will be the derivative for this given function by using the AB initio method. So here we have another function in question 2 part 1 where we have a function y is equal to square root of x plus 2. For that we have to find the derivative by using the principal method. So we can write it in this way: y is equal to x plus 2 power 1 by 2. So by using step 1, y plus delta y, that is equal to x plus delta x plus 2 power 1 by 2. So by taking y on the other side of the equation, that will become x plus 2 plus delta x power 1 by 2 minus y, and then by putting the value of y, we have x plus 2 plus delta x power 1 by 2 minus x plus 2 power 1 by 2. So here we have to simplify this one by taking x plus 2 common and converting it into binomial expression, and then by applying the binomial theorem we are able to simplify this expression. So here we have delta y is equal to x plus 2 power 1 by 2 into 1 plus delta x by x plus 2 whole power 1 by 2 minus x plus 2 power 1 by 2. So here we have 1 plus x power n in form of binomial expression. So by applying binomial theorem, this will become delta y is equal to x plus 2 power 1 by 2 into 1 plus nx. Our n is 1 by 2 into x plus 2. That will become 1 by 2 into x plus 2 into delta x, 1 plus nx, then n 1 by 2 into n minus 1, 1 by 2 minus 1 whole divided by 2 factorial into x square. That will be delta x by x plus 2 whole square. So neglecting the higher terms, and then at the end we have minus x plus 2 power 1 by 2. So now multiplying this term with these expressions of after reduction by using binomial theorem, we have delta y is equal to x plus 2 power 1 by 2 multiplied by 1, that is equal to x plus 2 power 1 by 2 plus x plus 2 power 1 by 2 divided by 2 into x plus 2. That means here we have its power 1 by 2. In the denominator its power is 1. So that is delta x plus 1 by 2 minus 1 minus 1 by 2, and into 1 by 2 that will become minus 1 by 4, and divided by 2 that will minus 1 by 8. So minus 1 by 8 into delta x square divided by x plus 2 whole square minus x plus 2 power 1 by 2. So here we have x plus 2 power 1 by 2, and at the end we have minus x plus 2 power 1 by 2. That will be cancelled with each other. So here we cancel it. So our remaining term here will become delta y is equal to, we write it in this way, 1 over 2 into x plus 2 power 1 into x plus 2 power minus 1 by 2. So when we take it into the denominator, this 1 by 2 will become minus 1 by 2, and we will take delta x as common from out of these two terms here. So we write it as delta x will be taken as common, and the second term will become minus 1 by 8 delta x whole divided by x plus 2 whole square, because here we have delta x square, so we taken delta x common, so that remains delta x. So write it in this way. Now by dividing directly, I am going to divide both sides with delta x. So delta y by delta x, this is equal to delta x by delta x into the first expression will become 1 by 2 into x plus 2 power 1 minus 1 by 2, that is equal to x plus 2 power 1 by 2. X plus 2 power 1 by 2 minus 1 by 8 delta x over x plus 2 whole square. Now, by applying limit on both sides of the equation, so we apply limit here, limit delta x approaches to 0, delta y by delta x, that is equal to, this is cancelled, limit delta x approaches to 0 of these two functions, 1 by 2, x plus 2 power 1 by 2 means 1 by 2 under root x plus 2, we can write it in this way as well, minus 1 over 8 into delta x over x plus 2 whole square. So now by applying the limit, the second term here we have delta x involved, so this whole term will become 0 because delta x approaches to 0. So dy by dx is equal to 1 by 2 under root x plus 2, that will be the required derivative for this given function by using the principal method. We have the last question of this exercise, in which we have to find the derivative of this given function by using the principal method. So let's start it once again, and by using those 4 steps we are able to find the derivative. So our y is equal to x plus a power minus 1 by 2. It's 1 over x plus a square root, or 1 over x plus a power 1 by 2. So we can write it as y is equal to x plus a power minus 1 by 2. So in first step we have to take y plus delta y, that is equal to x plus delta x plus a power minus 1 by 2. Now taking y on the other side of the equation, that is equal to x plus, we write it a before delta x, so x plus a plus delta x whole power minus 1 by 2 minus y. Now by placing the value of y, that is equal to x plus a plus delta x power minus 1 by 2 minus x plus a power minus 1 by 2, by placing the value of y, that is x plus a power minus 1 by 2. Now we have to simplify this and convert it into binomial expression, and then by applying the binomial expansion to reduce or simplify this expression. So here we have to take x plus a common, means we have to take x plus a power minus 1 by 2 common. The remaining term will become 1 plus delta x by x plus a whole power minus 1 by 2 minus x plus a power minus 1 by 2. So in this expression we have to apply the binomial expansion. So 1 plus nx plus n into n minus 1 by 2 factorial into x square plus so on. We have to take only the first 2 terms of the binomial expansion. So our delta y is equal to x plus a power minus 1 by 2 into 1 plus nx, its power n is equal to minus 1 by 2. So this will become 1 minus 1 by 2 into x plus a into delta x plus n minus 1 by 2 into n minus 1 minus 1 by 2 minus 1 whole divided by 2 factorial into x square, that will become delta x over x plus a whole square. We neglect the remaining terms, we only have to take the 2 terms of the binomial expansion. And the last term, that is minus x plus a power minus 1 by 2. Now multiplying by x plus a power minus 1 by 2 with whole this expression, and then we are going to simplify it. So our delta y is equal to when x plus a power minus 1 by 2 multiplied by 1, that is equal to x plus a power minus 1 by 2 minus x plus a power minus 1 by 2 multiplied by the second term. This will become x plus a power minus 1 by 2 divided by 2 over x plus a into delta x. Now we simplify this one, minus 1 by 2 minus 1, that is equal to, we take the LCM 2, so minus 1 and minus 2, that is equal to minus 3 by 2 for this one, and then minus 3 by 2 multiplied by minus 1 by 2, that is equal to 3 by 4. For this whole term we have a result of 3 by 4, so we write it as x plus a power minus 3 by 4 into x plus a power minus 1 by 2 into delta x square whole divided by x plus a power 2, and the last term minus x plus a power minus 1 by 2. So we have simplified this one. Again I am going to repeat this one. This term multiplied by 1, that remains the same one. Then the second term multiplied by x plus a power minus 1 by 2, that is equal to x plus a power minus 1 by 2 divided by 2 into x plus a into delta x. The simplification of this term I have solved that over there. That is equal to 3 by 4 multiplied by this term x plus a power minus 1 by 2, and this term delta x square taken separately, and then x plus a whole square by taking the square of both terms individually, and at the end the value of y. So this x plus a power minus 1 by 2 and minus x plus a power minus 1 by 2, they are cancelled with each other. So the remaining terms we have our delta y, that is equivalent to, we write it as minus 1 over, for this term I am taking this term x plus a power 1 by 2 into the denominator to make it positive, and adding the same terms, they have the same base and the powers will be added with each other. So I am writing it in that way. So that will become minus 1 by 2 into x plus a into x plus a power 1 by 2. So I have combined both of them into, or I can say that this is delta x minus delta x. For second term, so we write it as plus, here we have again we move this term in the denominator, so we write it as 3 by 4 delta x square whole divided by x plus a power 2 into x plus a power 1 by 2. So now by taking the simplification, I am removing the remaining one. So here so delta y, this is equal to minus delta x whole divided by 2 into x plus a power 1 plus 1 by 2, that is equal to 2 into x plus a power 3 by 2 plus 3 by 4 into delta x square whole divided by x plus a power 2 plus 1 by 2, that is equal to x plus a power 5 by 2. Power 2 plus 1 by 2, taking LCM, that will give us a power of 5 by 2. Now taking delta x common out of these two terms, so we have delta x into minus 1 over 2 into x plus a power 3 by 2 plus 3 by 4 delta x over x plus a power 5 by 2. We have taken delta x common, we have remaining one delta x because it was delta x square. So in the first term we have only delta x, so that will be taken as a common. So now by using step 3, by dividing both sides of the equation by delta x, so delta y by delta x, that is equal to delta x over delta x into this whole term remain the same. So this will be cancelled, and at the end, by applying the limit on both sides of the equation, so we have limit delta x approaches to 0, delta y by delta x, that is equal to limit delta x approaches to 0 minus 1 by 2 into x plus a power 3 by 2 plus 3 by 4 into delta x by x plus a power 5 by 2. So out of these two terms, in the second term we have delta x involved. So in the limit of delta x approaches to 0, so due to that the second term will become 0. So we only have the first term in which there is no delta x involved. So that will be treated as a constant term in which no limit is applied. So that will be our result for this given function, and our dy by dx, that is equal to minus 1 by 2 into x plus a power 3 by 2. This is our desired derivative for this given function, and this is the last question of this exercise, and that is going to be completed.